Hello. Before continuing to solve this example, this gentleman asked me a very good question. I want to share first. Okay. By definition, a function is continuous on a closed interval AB. Means f is continuous the definition is f is continuous at C for all C interior to AB. Means interior to this closed interval at any number C, f is continuous from both sides. F is continuous from the right at A. Only one-sided continuity. And C, f is continuous from the left at B, because B is the right endpoint of this closed interval. So we consider one-sided continuity. This is a definition for a real valued function of one variable on the interval. Loosely speaking, it is continuous at every point. Loosely speaking, continuous at each point of this interval, but at any point we can only talk about one-sided continuity. Okay. So loosely speaking, not so strict. Strictly speaking, f is not continuous here. If f is undefined on the left-hand side of this number A. So in this case, if the graph of f only this curve and outside this closed interval, no graph. Okay. In this case, continuous from the right at A means because by definition, we say that a function f is continuous at some point, we mean two-sided limit. Because continuous at A means, okay. Here, only from one side, not from both sides. So f is not continuous at A from one side, from the right at A. Similarly, loosely speaking, f is continuous at each point. When we face to an endpoint, we consider one-sided continuity. So this is just a loosely speaking. Strictly speaking, because only from one side, f is not continuous at B. Okay, formally. Now, if f is not continuous at A, then of course f is not differentiable at A. because differentiability implies continuity. When we talk about derivative or differentiability, we always consider two-sided limits of the difference quotient. Okay. So there is a question. Is this point or this number a critical number of the function f? In our textbook, if this number is in the domain of f, and here f is not differentiable, this is a critical number. This is a critical number according to the definition of in our textbook. In some textbook, the author already give the condition that the number is inferior to the domain or to the set under consideration. So in this textbook, strictly speaking, A is a critical number. But in the closed interval method, the step one is we only consider the critical points interior to this interval. If a critical point is an endpoint, we just call it an endpoint. Okay. So maybe endpoint is also a critical point according to our definition, but we emphasize once we are talking about the critical numbers, we will focus on numbers interior to this set. OK， 好，根据本书的定义呢，所谓的临界点是指一个函数在某一点或某个数，那个数要在定义域里面，导数为零或者是在那点不可为分。现在问题来了，如果一个函数在某个 B 区间上，就算是连续好了，意思在端点只能讲单边连续，那就不是单边连续不能保证一定连续。所以说不连续的话就不可为分，因为可为分一定要连续。因此端点到底算不算是临界点呢？根据本书的定义，它是。但是有些书本一开始讲临界数或临界点，就要求，要讨论的是对付的是相对极值或局部极值，就是讨论内部的点。那不管怎么说，在 B 区间法里面呢，我们要考虑一个函数在 B 区间上连续的话。要看它的最大值跟最小值，就算是有些边界点是临界点，但是呢，我们就把它叫做边界点，然后再讨论在这个区间内部的临界点。就算这个是临界点，我也把它叫做边界点，也没错嘛，啊，可以吧 ？So in this function, if we are not this function not restrict to this interval, then x can be f is defined for any real number, then 0 is not a critical number. Okay. Because at 0, the derivative is -1. And the 2 pi is not a critical number. Okay. Because if we consider for any x, then at 2 pi, this is a cosine 2 pi, this is 1, also -1. So derivative is not 0. Okay. So once we talk about the critical numbers, we will focus on those numbers interior to the interval. Okay. Maybe the endpoints are also critical points, but we just split to 2 parts. Endpoints, critical numbers interior to this interval. Okay, and find the values on those points. The largest one will be the maximum, and the smallest one will be the minimum of the continuous function of this closed bounded interval. Very good. So, I think this explanation will make things more clear. we review some definitions, and we review some old objects. Differentiability implies continuity. If this is an endpoint and one side of this point, this function is undefined, definitely this function is not continuous at this endpoint. This function only continues from one side at this point. If a function is not continuous here, then it is not differentiable here, because differentiability implies continuity. If f is differentiable at A, then f must be continuous at A. Now, the value of f at pi over 3 is pi over 3 minus square root of 3. Approximately 1. This is so this one is negative, less than 0. Okay, here, almost 3. Greater than uh, 5 plus so this one is greater than this one. Okay. In summary, we have f of 0 is 0, and this value is less than 0. f2 pi is 2 pi of, this one is greater than 0. But this value is more than 6.7 is greater than this one. So this is the maximum of the function on that interval, and this number is minimum. Okay, this is the answer. Do you know the pi approximately 3.14 and square root of 1.732 maybe. Then square root of 2. Maybe some okay. This is the section of 3.1. In this section, we learn two main theorems. One is extreme value theorem. If a function which is continuous on a closed bounded interval, then this function has both maximum and a minimum value. Two, Fermat's theorem. Fermat's theorem. If f has a local minimum at some number c, of course at c may be this function differentiable or non-differentiable. If it is differentiable and f of c is a local extreme value, then f prime c equals 0. Okay. The next section entitled the mean value theorem. Mean value theorem may be the most important theorem for the theory of calculus. Of course.